Oh yes, I have. Everybody say hi to Miss A. Alright, so we're talking about P5, solving equations. A couple things I want to go over first is types of equations. You know about a linear equation. A linear equation is when you have a y and an x, and the x is to the first degree. A quadratic equation is when you have y to the second degree. And whenever you have a quadratic equation, you want to try to make it equal 0. We'll talk about that later. For the most part, in order to use the quadratic formula or to factor, you need it to equal 0. The other kind of equation is called a cubic. That's when you have x to the third. A quartic is x to the fourth. A radical equation is exactly what it sounds like, an equation that has a square root in it. And a rational equation is when you have fractions, plus 5 over x minus 2, something like that. Okay, those are all the different types of equations we're going to talk about solving in this section, and we're going to talk about lots of different methods of solving. The important thing to understand is that when we talk about solutions to all of these, not necessarily a linear, but a solution is also called roots, and those are the x-intercepts. Wherever the graph crosses the x-axis is called a root or a solution to the equation. So when we want to find these, we're going to use the function on our calculator that's called 0. Oh, it's also called zeros. Okay, let me make another slide. Solutions equals roots equals x-intercepts equals zeros. Those are all words that people use to describe the answers to an equation. So for instance, the first equation we're going to talk about solving is 2x squared minus 3x minus 2. Now what I want you to do on your calculator is hit the y equals button. Actually, you know what? I'm going to talk about doing it graphically in class. So please write on the top of your notes, show graphically in class, because that way I know that we all have the same calculator and we can all do it together. So now I'm going to solve that same equation. Don't know why I just erased it. Algebraically, 2x squared minus 3x minus 2 equals 0. This is a quadratic. The methods of solving quadratics, there are lots of them. Methods of solving quadratics. The first method is factoring. Now factoring doesn't always work. It has to be a factorable quadratic. So you're thinking, well, I'm not going to learn that. I'm always going to do it another way. There's two reasons why you can't do that. One, sometimes the directions say solve by factoring, so you actually have to do it the way they say. Two, it's actually a lot easier to solve it by factoring in some cases. So you have to learn how to solve by factoring. Another way is to use the quadratic formula. This writing is not going very well for me. Quadratic formula. And we're going to go over that. Hopefully you remember it. That method will always work. You can solve any quadratic using the quadratic formula. The problem is sometimes it's harder to use the formula than it is to factor. And the third way is by taking square roots of both sides. And sometimes there's a fourth way called completing the square, which also involves taking square roots. But we're going to look at all four of these methods, and this is just for quadratics. So we're going to try to factor this one. And I always give factoring a shot. I'll try two things, and if it doesn't work, I go right to the quadratic formula. But I know this one's going to work, mostly because I have the answers in front of me. But anyway, the easiest way to get to 2x squared is 2x and x. It's actually the only way, because you know you have to have an x in each parentheses, or else it's not factored. And you can't have a 2x squared and a 1. That wouldn't work. So anytime your equation starts with 2x squared, you're going to have 2x and x. I know that I need a 2 here and a 1 here, or a 2 here and a 1 here. Keep in mind, whatever number goes here, when I check it, when I FOIL, remember factoring is undoing FOIL. When I multiply those two together and add it to this inside term, I have to get negative 3. So if I put a 1 here and a 2 here, my outside term is going to be 2x, my inside term is going to be 2x. And no matter what the signs are here, I'm never going to get to negative 3. 2 minus 2, 2 plus 2, negative 2 plus 2, no matter what, I'm never going to get to negative 3. So it must not be a 1 here and a 2 here. Now remember, I'm talking about factors of this last term. So the only other possibility is to switch the 1 and the 2. There's no other way to get 2 besides 1 and 2. So if I put the 2 here and the 1 here, now my outside term is 4x and my inside term is 1x, and I need them to add up to negative 3. In order for these two terms to add up to negative 3, 4 must be negative and 1 must be positive. In order to get a negative 4x, I have to do positive 2. I'm going to put a minus sign here and a plus sign here. So let's back up and see what we have. These are the two factors. Now in order for factor times factor to equal 0, one or both of the factors need to be 0. Let me say that again. This right here is just a number. For instance, let's pick a number for x, a random number like 5. If x was 5, this would be 2 times 5 is 10, plus 1 is 11, 5 minus 2 is 3, 11 times 3 would be 33, which clearly does not equal 0. You just have to remember that even though it looks like two numbers, when you plug in a value for x, this turns into a single number times a single number. And in order for a number times a number to equal 0, either this number over here has to equal 0, or this number over here has to equal 0. Because if this equals 0, then 0 times anything will give you 0. And if this equals 0, then 0 times anything will give you 0. So I'm going to solve these two equations separately. X equals negative a half, x equals 2. Those are my solutions to this equation. When I show you on the calculator, when we graph this in class, you're going to see that it's a parabola that crosses the x-axis at negative a half and 2. And it's going to look like this. These are the solutions, the roots, the x-intercepts, the zeros of this equation. And we solved it by factoring. Another way to solve a quadratic equation is to take square roots. So for instance, if I have this problem, I could FOIL this out, get it equal to 0, and use the quadratic formula. I could do that. I might even be able to factor it, and I'll show you that after. I'll show it to you right now. So over here, on a side note, I'm going to solve this by factoring. In order to solve it by factoring, I have to get it to equal 0. So first I'm going to FOIL this out. All I did was rewrite 2x minus 1 squared as 2x minus 1 times 2x minus 1. When I FOIL it, I get 4x squared. Outside is minus 2x. Inside is minus 2x. And last is plus 1. And that equals 9. So I want to get it equal to 0. 4x squared minus 4x. I'm going to go minus 9 from both sides, so minus 8 equals 0. Now remember, we just talked about factoring and how important it is. Here there's a GCF of 4. I'm going to factor out of 4, and I'm left with x squared minus x minus 2 equals 0. Bring down the 4. I can factor this into x minus 2, x plus 1, because if I FOIL this, I will get this trinomial, because my first is x squared, my outside is plus 1x, my inside is minus 2x, and 1 minus 2 gives me the negative 1, and negative 2 times 1 is negative 2. So now, if I say 4 times a number equals 0, then the 4 can't be 0. So either this term right here has to equal 0, so x equals 2, or this term right here has to equal 0, so x equals negative 1. And those are the two solutions. Those are the answers. 2 and -1 will make, now let's check it. Plug in 2 for x. 2 times 2 is 4, minus 1 is 3, 3 squared is 9. 9 equals 9. That works. Check -1. 2 times -1 is -2, minus 1 is -3. When you square -3, you get positive 9. These are the two solutions to this equation. But that was a lot of steps. We had to FOIL, then we had to subtract, then we had to factor, then we had to factor again. If you see a quadratic equation with a perfect square on the left and a perfect square on the right, you can simply take the square root of both sides. When you square root something that has been squared, you simply get what you started with, what's underneath the square root symbol. So for instance, this would be 2x minus 1. When you take the square root of 9, you get plus or minus 3. Now you only put the plus or minus on one side, and I'll explain why in a minute, because some people get really upset about that. I should put a plus or minus here, but I'll show you why it doesn't matter. Okay, so now we actually have two separate equations. Now let me show you a very common mistake. So many people do this. Right from here they go plus 1, so 2x equals 4, and x equals plus or minus 2. That is not what's happening here. That is not okay. You can't add something to a plus or a minus. You have to understand what the plus and minus are actually telling you. This is really saying 2x minus 1 equals positive 3, or 2x minus 1 equals negative 3. Two totally separate equations that have to be solved independently of each other. So if 2x plus minus 1 equals 3 and I add 1, then 2x equals 4 and x equals 2, just like we got over here. If I add 1 over here, 2x equals negative 2, because this is negative 3, and if I add 1 I get negative 2, x equals negative 1. You get the same exact answers because it's the same equation solved two different ways. These are the two solutions, the two roots. Over here, we solved it by factoring. Here, we solved it by extracting square roots or taking square roots. So that's how you do that. Let me just show you real quick. If x squared equals 4 and we want to solve this equation, we're going to take the square root of both sides. So we're going to go square root. If I wrote a plus or a minus on both sides, watch what would happen. Let's say I take the plus from here and the plus from here, so x equals 2. Let's say I take the minus from here and the plus from here, so that would say negative x equals positive 2. But if negative x equals positive 2, then what you're really saying is x equals negative 2. And then if I take the positive here and the negative here, then I have positive x equals negative 2. And if I take the negative here and the negative here, I say negative x equals negative 2, so x equals positive 2. So you have 4 different solutions, but 2 of them repeat. Basically what I'm showing you here is that when you write a plus or minus, you only do it on one side, because otherwise you're just repeating values and making more work for yourself. So if we were to solve this equation, we would simply say x equals plus or minus 2. Okay, so we've done factoring, we've done extracting square roots. Now we are going to do completing the square. I don't really want to show you completing the square. I'm going to go to the quadratic formula. Okay, I don't think you need to learn completing the square. We're actually going to skip it altogether. How about that? So, quadratic formula. Let's see. In order to use the quadratic formula, first you have to get it equal to 0. Make your equation equal 0. So we're going to subtract 5 from both sides. Okay. Then I like to list my a, b, and c. Over on the side, I think you should write a equals 3, b equals negative 6, c equals negative 5. And the reason is, When you go back and plug numbers in, you don't want to constantly be looking at this and thinking every time. Once they're listed over here, there's no more thinking. You've removed the thinking from the equation. Now you just plug stuff in. Now hopefully you remember the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. If you didn't learn that, I'm sorry. It's kind of fun. I probably don't sing it as well as your other teachers, but let's plug in everything we know. X equals negative. B is negative 6. Remember, I'm plugging everything in parentheses, at least for the first time, so you can get used to it. 4 times 3 times negative 5 all over 2 times 3. Now I'm going to tell you two little tricks. The first one is you don't have to show this much work. You just take the opposite of b. Some people even teach it as x equals opposite b. I don't like the word opposite, but basically if your b is negative, this is positive. If your b is positive, this is negative. So that takes out a little bit of room for error with all these parentheses and negative signs. Just write the opposite of b. So I'm going to put a 6 here. The other thing that really messes people up is this whole term right here. Personally, I think you should be squaring these in your head instead of trying to make your calculator do it. You should know that this answer right here is always positive. When you square something, you always get a positive number. And sometimes if you type it in your calculator, if you don't use parentheses correctly, it will give you the wrong answer. So I really, really hope that you don't type this term in your calculator. I hope you just say, oh yeah, I know that negative 6 times negative 6 is 36, and you just write that. Because now you could essentially type this all in exactly as it appears. But keep in mind, this plus or minus means you have two separate equations. You have 6 plus the square root of whatever you get here, 96 all over 6. And you have 6 minus the square root of 96 all over 6. Now if it says your answer needs to be exact, then you can't use your calculator. You have to put this in simplest radical form. So let's talk about that. We have 6 plus radical 96 over 6 and 6 minus radical 96 over 6. Radical 96, let's see, what goes into radical 96? Well, we're going to do prime factorization. I know 2 goes into it. 48 times 6 and 8, 2 and 3, 2 and 2 and 2. So I have double 2's, so I have 4 root 6. So 16 times 6 is 96. Yes, that's right. So when I simplify my quadratic formula, when I go to the last step and I simplify, my answer is going to be x equals 6 plus or minus 4 root 6 all over 6. Now again, we can simplify. I call this triangle canceling. The only way you can simplify this fraction is if these three numbers have a common factor. For instance, if this was x equals 5 plus or minus 4 root 6 over 6, you would be done. There's nothing more you can do to simplify this. But since they all have a common factor of 2, we can divide each of those three terms by 2 for simplest form. So our answer will be x equals 3 plus or minus 2 root 6 over 3. That's done in simplest form, and that's as exact as you can get. If it says to the nearest hundredth or something, then you just type in 3 plus 2 root 6, enter, divide by 3, and get your decimals. Now, the reason we write them like this, let's go back and do the one we did first. 2x squared minus 3x minus 2. Let's solve that with the quadratic formula, so we can talk about what the two different plus and minus means. 2x squared minus 3x minus 2 equals 0. This is a minus, this is a minus. So it already equals 0, so now we're going to put our a is 2, b is negative 3, c is negative 2, and we're going to go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug it in. Opposite of b is positive 3. b squared is 9 minus 4 times negative 2. Oops, it's positive 2. That's an equal sign. 4 times 2 times negative 2, because that's c, all over 2 times 2. So x equals 3 plus or minus the square root of, this is 36 plus 9, wait a minute, 8 times 2 is 16, 9 plus 16 is 25, all over 4. Now here's where you can see why you have to write two separate equations. So we have x equals 3 plus root 25 over 4, and x equals 3 minus root 25 over 4. But we know that root 25 is 5. So 3 plus 5 over 4 is just 2. 3 minus 5 over 4 is negative 1/2. Those are the same answers we got at the beginning when we factored, but now we did it using the quadratic formula. You can see it takes a lot more work, but you always get the right answer. Let's see. So I want you to try a few on your own. I will show you all the calculator stuff in class, but I want you to try this one. 2x plus 3 squared equals 169. Now, I want you to do it by factoring, by square roots, and by quadratic formula. I'm actually going to check this as part of your notes. I'm going to see that you solved this all 3 ways, and I want to see it. Now, on the next 3 slides, I'm going to show you how to do it, but right now I want you to try it on your own and see if you can do it. So pause the video and try it. So here we go. Factoring. 2x plus 3 squared equals 169. By factoring means I have to get it equal to 0. So first I have to FOIL 2x plus 3 times 2x plus 3. So that gives me 4x squared plus 6x plus 6x plus 9. Combine like terms. 4x squared plus 12x. I'm going to minus 169 from both sides. Negative 160. I'm going to factor out a 4. Now it's just a coincidence that this is also a 4. It's not always a 4. So now I'm going to factor this. X plus 8, x minus 5. So x equals negative 8, x equals 5. Those are the answers, but I solved it by factoring. Now I'm going to solve it by taking square roots. When you take the square root of both sides, you get 2x plus 3 equals plus or minus 13. So 2x plus 3 equals 13. 2x plus 3 equals negative 13. Minus 3. 2x equals 10. X equals 5. Minus 3. 2x equals negative 16. X equals negative 8. Same exact answers we got when we factored, but this was a lot less steps because we did it by taking square roots. Now I'm going to do it by the quadratic formula. Now the quadratic formula and factoring both start out the same way. You still have to FOIL, so I'm just going to use the foiling that I had from the first one. And you have to get it equal to 0. So this was how I did it on the factoring one when I got it equal to 0. Now I could still factor out a 4, and then I could use my factored form. I'll show you what I mean. If I factor out a 4, I'm still going to use the quadratic formula. I'm just making it easier on myself. Because if you think about it, if I divide both sides by 4 right now, the 4 goes away, and all I have left are these numbers, which is much easier to do the quadratic formula with a equals 1 and b equals 3 and c equals negative 40. That's easier than using 4, 12, and negative 160. So quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So when I plug it in, the opposite of b is negative 3 plus or minus the square root, b squared is 9, minus 4 times 1 times negative 40 all over 2. X equals negative 3 plus or minus the square root. 40 times 4 is 160 plus 9 is 169 all over 2. Remember, this is 13. So I'm going to go x equals negative 3 plus 13 over 2, which is 5. And x equals negative 3 minus 13 over 2, which is negative 8. Same answers we got all the other times. There are some harder ones that we're going to do in class, but I'm going to show you how to do most of them on the calculator, which you are going to love. But hopefully this made sense and you got something out of it, because this is a really important topic. Okay.